right. Thank you very much. And we will jump in and explore this world of threat modeling, what we're calling uncovering vulnerabilities without looking at code. So let me tell you a little bit about myself from a background perspective. As was already said, I'm the CEO and co-founder of Security Journey. I've been involved in the world of security for a long time, almost 25 years at this stage. And I spent 10 years of my career at Cisco focusing on educating Cisco's 25,000 developers on all things security. I do have a podcast as well. I'm the co-host of the Application Security Podcast. So if you want to look that up, and we've done about 175 episodes interviewing people across the application security gamut about really what makes them tick, what they've seen be successful, what are the new tools, the new processes, all kinds of different types of information. So if you want to check that out, that'd be something I think you get some value out of as well. I'm also a big fan of Twitter. So if you're on Twitter, would be happy to speak about all things or tweet about all things back and forth with you about threat modeling. So feel free to look me up on Twitter, and we can always continue the conversation there after this session wraps up for today. So definitely want to get your questions in the webinar panel. So as we're going through, throw those in there. Any other questions you have? That's one of my goals as an educator, as a teacher. So I want to not just sit here and lecture, but I want to make sure you get the most out of this experience. So please put those questions in, and I will address all of them before I hang up. So when we think about a high-level agenda about what I want to take you through today, we're going to start by introducing this idea of threat modeling. And from there, I'm going to share a threat modeling reference that you can use. And then I'll take you through what I think of as the simple threat modeling process that you can take and apply to wherever it is you're working, whatever you're looking at. I think you'll see how you can take this process and make it a part of how you approach analyzing and thinking about the security challenges that exist in whatever it is that you're responsible for. I'm going to share a couple of different tools for threat modeling that are more focused on the world of application security, more on developers and what developers can use. And then what we're going to do at the final stages of this webinar is we're going to go to work. We're going to do some threat modeling. So as a group, I'm going to share a diagram with you and let you identify some of the threats and throw them out, and I'll react to them in real time when we get there. So that's my plan for what I want to go through today. So when we think about the modern application, a lot of you are probably looking at this going, yeah, I agree. The modern application is complex in this world that we live in now. But if we kind of peel back the layers a little bit and think about what do we see, what do we find in a modern application? When you think about a web application, it might be running in a Docker container. It might be exposing or communicating with or providing a backend API. It could be a mobile app that's connecting to that same backend API. You could be using serverless functions. You could even be engaging in the Internet of Things, where your web application is driving some piece of hardware that's sitting in somebody's house, controlling the temperature and letting them use an app to be able to control that temperature from their phone and cause the temperature to rise or fall inside of their house. So we think about all the different pieces that fit together here. This is a very complicated world and technology landscape that we live in right now. And so one of the things that is front and center for everybody in the world that we live in now is security and privacy. And how do we bring a secure setup and configuration to all of these different components? How do we consider privacy? This is what we're going to talk about today. So when I think about a definition of threat modeling, for me and a number of my colleagues, and I'll get to that in a few minutes, as far as how a number of my colleagues and I got together from the industry to define what threat modeling is, this is the definition that we came up with. So threat modeling in its most simplest form is analyzing representations of a system to highlight concerns about security and privacy characteristics. So if we break this down, analyzing representations of a system. So what's a representation? So it's a picture, it's a diagram. It's a verbal description where somebody says, this is what the system does. So you want to be able to analyze that representation of the system, whether it's a picture, that's what I happen to like, so that you can pinpoint, discover, and ultimately fix any of the concerns that you can see or determine from a security and privacy perspective. So that's threat modeling. Now, I want to just give you this thought about what I consider to be the truth about threat modeling. So threat modeling, it's basic security hygiene. This is like brushing your teeth. Threat modeling is something that you should be doing early and often. And so let's step back for a second and think about, if you're somebody who's coming into this conversation from the world of application or product security, threat modeling for you means looking at a new feature that your developers might be working on and pinpointing what are the security and privacy challenges so that we can adjust the design before that feature goes into production. But there's other places that threat modeling can be used as well. You can use threat modeling from looking at a network architecture. You can use threat modeling in the risk assessment or risk and audit governance and the GRC kind of process. You can use threat modeling to analyze answers you've been provided from a questionnaire. So the point is, threat modeling is not something that's specific to AppSec. It's something that can be applied to wherever you fit into the world of security. So what are the benefits? I'm gonna take the conversation more into the application and product security specific area. That's going to be my focus. And so when I think about the benefits of threat modeling, first of all, we're ensuring that security is being built into everything during development. We've come a long way as an industry in how we apply security controls, and we do the right thing for security, but we've still got a ways to go. And so what we want to do is we want to use threat modeling to enable us to understand, are we considering security and adding the right stuff at every feature that goes out the door into production? Every network architecture, every change we make to our tools and things that we provide from an IT perspective, all of those things, we want to make sure that security is being considered there. The second benefit is security problems are found and fixed early in the process. Back to kind of a developer perspective, if I'm building a new feature and I discover the fact that there is a security problem after I've pushed that feature to production, now I've got to go back. And one of the things that developers dislike is something called rework. And rework just means I worked on this feature, I committed my code, the feature should have pushed out to production, but there was a problem. Now I've got to stop what I'm doing, working on the next new feature, and I've got to reload in my brain all of the things about the feature that I thought I'd already finished, and I've got to try to fix the problem and make it work correctly. So one of the things threat modeling does, it helps us see those security and privacy issues earlier in the process so that we don't have to ask developers to constantly be performing rework. The third benefit is the security mindset's encouraging everyone. I want to see a world in the future where everybody inside of your product organization, your application development organization, embraces this idea of a security mindset, meaning they start to think like a security person. I don't want people to think like an attacker. We've got plenty of attackers in the world. We don't need anyone else thinking like that. I want your teams to be thinking like security people. And threat modeling is something we can use to teach them how to do that, how to be successful thinking with that mindset. So when we think about this idea of the security feedback loop, this is a constant loop that we're in when we're building anything. And so what threat modeling is enabling us to do is, first of all, identify what are the threats, what are those challenges to the security and privacy characteristics of whatever it is that we're working on here. And so once we identify the potential security or privacy challenge, now we can evaluate what are the mitigations. What can we do to fix that problem? What can we change in the design so that that problem goes away? We've mitigated it. And once we evaluate what the mitigations is, then we can actually change the design itself so that we take whatever that idea or that thing that we detected and we apply that mitigation to the design. We call this the security feedback loop, though, because this is going to be constantly going on for the whole lifetime of whatever it is that you're building. There is no, hey, we did this loop, we went around one time and we think we found all the security issues. No, you're adding new code, you're adding new features, you're adding new functionalities and capabilities. In 6 months from now, your application or product is not going to look the same as it does today. And that's why we've got this security feedback loop. We're always going around in the loop until we decide to stop shipping the product or decommission the application. We've got to continuously go around this security feedback loop. So I want to clarify something here pretty early And I want you to just understand that threat modeling is not an exact science. I cannot give you an equation. And if you fill in all the inputs, you're going to get the same exact results from the threat modeling process that I'm going to do. Because threat modeling is influenced by your experience, your technical knowledge, historical things that you've been a part of or that you've read about or understood. And so everybody comes to the threat modeling process with a different perspective and a different set of experiences and things that you've done, in the product world, for example. The threat modeling is not an exact science. I can't just give you an equation. I wish I could, but there is no equation that allows you to say, if I just put in all these values, I get these values to come out, and it's always the same from different people. But that's okay, because it's okay for you to have a different perspective than I do, because I'm going to think up a series of threats. You're going to think up a series of threats against the same thing that we're looking at. Some of them are going to be the same, more than likely, but you may think of something that I hadn't even ever imagined. And so that's some of the beauty of using this threat modeling process and threat modeling ideas, that you have the ability to really tap into what other people's experience is and learn from them. So with threat modeling, perfect is the enemy of good. And I say this because threat modeling is one of these things where you can say, if I just put in a few more hours, I think I can get to I can get to the perfect threat model. And so the takeaway here is, there is no such thing as a perfect threat model, because there is no way to consider all of the various information that's out there. Threat modeling is an iterative process about how do we constantly make the security and privacy characteristics of what we're building better. When we think about this idea of, perfect is the enemy of good, between nothing and something, that's a measurable distance. We can measure how much time, how much effort, how many resources it's going to take to get there. Going from something to perfection, that's an infinite distance. We're never going to get there. And so perfect is the enemy of good when we're doing threat modeling. We want to focus on just good. So I want you to kind of go through this little thought experiment with me here for a second. And because what I want to challenge you might be sitting here thinking, okay, Chris has told me a little bit about threat modeling. I kind of have an idea what he's talking about here, but I've never done it. I don't have any experience in it. I gotta learn this. So I want to challenge you a little bit to say, you're already a pretty good threat modeler. I would even argue you're bordering on an expert in threat modeling. Imagine this scenario. You open the front door of your house, you step out onto your porch, and your mission in this moment is to walk a small child to school. Could be your son or daughter, could be your niece or nephew, could be whoever you want to walk to school. Someone has asked you to walk this child to school. As you're standing there on the porch with the small child standing next to you, you hear and you look up and you see cars going by in front of the house. The speed limit's 25 miles an hour in front of your house, but those cars are really whipping back and forth. Like they're probably going 50 miles an hour. So what do? You reach down and grab the child's hand and say, hey, hold on to my hand here while we're walking down the sidewalk. I need to make sure you're safe. So what just happened? Well, you just threat modeled. You looked at that. You identified a threat. The cars were driving too fast on the street. They could potentially hit the child if the child ran off the sidewalk, not paying attention. Your mitigation was, I'm going to take the child's hand and I'm going to ensure that the child doesn't move off the sidewalk. Okay, so you threat modeled. Let's do it again. As you start walking down the sidewalk, you hear a dog. Doesn't sound like a very nice dog, but you hear a dog barking off in the distance in the direction that you are walking. So what do? Well, maybe we'll go around the block and we'll come back around and we'll kind of bypass this dog that we hear barking, because we don't really know if it's a nice dog or a mean dog. You've identified a threat. There's a dog. If we walked up to the dog could bite the child. The dog could bite you. Your mitigation is, I'm going to reroute and walk around the block, a little longer of a walk, but no chance of the dog biting me. And then even with the sun's beating down on you as you're there. So there is a threat that you could get a sunburn. The child could get a sunburn. The mitigation is you're going to apply sunscreen, hopefully before you left. The point here is that you, in your own kind of human capacity, you already do a lot of threat modeling. What we're going to do now is we're going to say, how do we take we tap into this approach, these ideas? How do we apply this to the things that we work on, the things that we build? So when we think about specifically about finding problems in software that we're writing, there's a number of different ways that we can try to find problems. So we have tools in application security, static application security testing, SAST, dynamic application security testing, DAST. We have the ability to do code review, just go and pour through all the code that's been written and try to see if there's any security issues. We can also pen test. We can try to break the feature, the product, the application. We can also just hope that we're lucky, and maybe we just, randomly choose a place in the code and we find an issue or vulnerability there or something. So those are our possible ways to find a particular problem. But now, what does it cost to find, for example, let's say that we're missing authentication inside of something that we're designing. Well, if we're missing authentication, what that means is we forgot to add the security control that's going to apply a username and password to somebody logging into our feature, our product, our application. Well, static application security testing and dynamic application security testing, these tools don't find, this is a design flaw. So those tools can't find, you can't just run a tool and have it find the problem for you. Okay, well, what if we did a code review? Well, it's probably going to take you anywhere from 10 to 100 hours to scour through all the code. And there's a chance you'll miss it because code review is a human endeavor. You could do a pen test and they would likely find that. But, to get a solid pen test done of your system, you're looking at, at least 50,000 US dollars, maybe 100,000. But using the threat modeling process in a maximum of 8 hours, you'll find this problem. And so what I wanted to show you here is threat modeling can also be a cost savings and a resource savings, and it can find something that some of these things wouldn't, like SAST and DAST wouldn't even be able to find. So I want to mention this reference to you and give you just a little bit of context about what it is. I had an opportunity to be a part of the creation of this document called the Threat Modeling Manifesto. And our job, our approach here was to gather a group of people that spend a lot of time teaching and writing books and blog posts and doing conference talks on threat modeling and get us all together and say, let's see what we can all agree on when it comes to threat modeling. And so I've got a list of the people there that were part of the Threat Modeling Manifesto. I was lucky to be included with this group of awesome folks from all over the world. And so I offer this to you as a reference just to help you as a framework for what are the things I have to consider? What are some of the issues that I have to wrestle with when it comes to threat modeling? And you'll find that document at threatmodelingmanifesto.org. And it's pretty simple. We got our inspiration from the Agile Manifesto. You'll see some commonality between that, but I just want to list that as a reference for as you're continuing on your threat modeling journey. It's a solid document that's been put together by people that really are passionate about threat modeling. And I think that you'll learn a lot just by grabbing that document and being able to read through it. So when we think about boiling threat modeling down to its most basic pieces, a friend of mine, Adam Shostak, a few years ago, put together this list of the 4 key questions for threat modeling. And at the end of the day, if you only take away one thing from this whole conversation that we're having today, it's you should take away the 4 key questions because you can apply this to anything that you're looking at. And so the first question you ask yourself is, what are we working on? What is the scope? What are we trying to do here? And then you ask, what are the threats? What can go wrong in what we're looking at? And then the third question is, what are we going to do about it? So this is our mitigation step. What are we going to do to make these things that could go wrong go away? And then the final question is, did we do a good enough job? This is our retrospective step, asking ourselves, hey, is there more work we need to do here? Did we do a good enough job? Can we put our stamp on it and say, yeah, we feel pretty good about this one? Or do we need to come back in a future endeavor and spend some more resources, just to catch up and get this threat model to the point where we feel good about it? So that's the 4 key questions. And so what I'm showing you here, this is my process that I've refined over the last decade for how I teach people how to threat model. And so I like to break threat modeling down into 5 steps: scope, draw, analyze, mitigate, and document. So with scope, I want us to just answer that question. What are we building? What is the effort that we're undertaking here? What are the constraints on what we're going to do our threat model on? And then the second step for my process is draw. I like to use data flow diagrams. I'm going to show you how you use those in the threat modeling process. I like a visual representation. It helps me to see and to draw a picture and then try to figure out what the threats are versus just reading a bunch of text. Different people apply this representation creation in different ways. That's how I teach it, because that's how it makes sense to me. The third step is analyze. We're going to look at that picture and say, okay, what are the threats? We're going to use a methodology to be able to do that. And then our fourth step is mitigate. How are we going to, what security controls are we going to apply to cancel out these threats that we've identified? And then we got to document. We got to write down what we came up with. We can't just have a meeting, have a long discussion, and then we walk away with no action items, because then, we just wasted everybody's time, because there's going to be very little actual improvement that's going to come as a result of that. So I've also layered Adam's 4 questions underneath this to say, what are we building? For me, that's scoping and then drawing a picture. What can go wrong is analyze. What are we going to do about it is mitigate. And then do we do a good enough job? That's what I want to see in the document step. So choosing a scope is really step 1 in this threat modeling process. And so choosing a scope is considering, what are we going to do the threat model on? What are the constraints that we're going to wrap around whatever it is that we're going to do here? And so one of the challenges a lot of people have is when they start threat modeling, they're like, let's threat model our entire system. The challenge there is threat modeling an entire system could take months or 6 months, and you may never get to the point where you're finished with it, because it's depending on how complex your system is. It's definitely not something you want to do as someone who's new to threat modeling. So you can also try to do a threat model of a subsystem or a service. But what I like to do, and what I focus on, is the feature level. So when we're talking about a piece of software, we're talking about, hey, a developer, a product manager has identified, hey, we want to build this new feature for our customers. And so the developers are picking up this small feature, and that's what they're building. That's the scope I like to use for threat modeling, because it's constrained. It allows me to stay within that 8-hour maximum hour kind of allocation I was talking about previously. And so that's what we do from a scoping perspective. Now we got to understand very early, who are the players involved in that can access our feature. So do we have users that are accessing the feature? Do we have administrators? Do we have attackers? We always have attackers, by the way. If there's an interface to the internet, there's always an attacker somewhere who's going to be pounding on that door, trying to find a way to get in. But I like very early to just set the stage for myself and say, okay, with this feature, who's using it? Who's attacking it? Who's coming after it? And that's identifying the users and actors. And then what I like to do is what I call an attack surface analysis. So I like to step back once again and say, what are the ways that one of these users can talk to this feature? So does the feature accept network packets in some way? Is it a web-based interface? Is it some other protocol that is different than the web interface? Is this being used for administration? Is it a command line interface? Is it a system daemon that's answering? Like, what are we able to talk to? Because by understanding our attack surface, sometimes we could look at our attack surface analysis and we say, wow, we've got 47 interfaces that an attacker or a user are using to come into this feature. Do we really need all 47 of those? You start to do some analysis, you're like, we only need 4 of these. We have 43 additional interfaces that we're exposing that we should not even have going out to the internet, or something that a user or attacker could come in and talk to the feature with. So attack surface analysis is about, 1, understanding and identifying what are the interfaces that are available, and 2, looking at them and saying, do we actually need all of these interfaces turned on, or can we just throw some of them away right from the beginning? So when we draw a data flow diagram, this is the general approach that I use. So if you did data flow diagrams in college, you're thinking, there's 47 different, I keep using 47, let's use 53. There's 53 different types of shapes and stuff that I can put in here. Well, the good news about threat modeling and the data flow diagram approach that I use is there's really only 5. There's external entity, data flow, process, trust boundary, and data store. So An external entity is anyone on the public internet who's trying to come in and use your feature, or maybe they're coming across some other network or something, but somebody who is outside what it is that you're building. Those external entities talk to your feature using a data flow. And the process models the unit of work, the units of work that are being done inside the feature. And then the data store, this is your databases, your files. Where are you storing things so that when you need them again, the process can extract that data when the user comes back next time? Then the most important element that you see on a data flow diagram is your trust boundary, because your trust boundary separates the outside from the inside. So when you hand me a data flow diagram that you've created, the first thing I do is I find the trust boundary and I look and see what's crossing it, because that's really where the interesting things are that are happening in the world of threat modeling. Because if you have a bunch of stuff happening inside the trust boundary, but there's no way an attacker can talk to it, great. Then that's a relatively secure system. If you have lots of different data flows that are crossing the trust boundary, there's lots of, once again, like I said, in an attack service, there's lots of ways for an attacker to try to access our application, get to our data. And so that's why we always look to the trust boundary very early on. So I've got an example here of a data flow diagram using a technology I recommend and have been recommending for probably 20 years that nobody uses, Telnet. But Telnet makes a great example because it's crazily insecure. Like it's terrible from a security perspective. So if we trace through this data flow diagram, just to catch you up on what I'm showing you here, we've got an administrator. They're sitting outside the trust boundary. They want to connect to a system. They connect over that data flow that crosses the trust boundary to the Telnet D or the Telnet daemon. That Telnet daemon accesses the etc password file on the host to look up the password. So as an admin, you send in your username and a password. The Telnet D checks the etc password and decides, do I allow you to have a shell on this system and run commands, or do I say access denied? So I like to use attributes as well when I draw a data flow diagram, just because it helps me to capture what is happening on some of these different elements in the diagram. So if we move left to right, you'll see I have a functional attribute and a data attribute. And so the functional attributes of my data flow between the admin and the Telnet D is we're using a protocol. That protocol is Telnet. It's an internet RFC, request for comments, internet standard. Now, the data is the same across this entire data flow diagram. I'm using username and password as what's being passed around here. Now, but you can also see from a functional perspective, I've identified Telnet D as a daemon. There's a system call that's happening between Telnet D to get to the etc password file, and that is a file. And so what these attributes do is they really just help us to decode and describe what's happening in our data flow diagram. Now, the longer you do threat modeling, you'll start to not write these attributes down. But I find it's an easier way in the early times of threat modeling to really capture and describe what's happening on a given data flow diagram. So now let's talk about analyzing the data flow diagram. And we're going to use a mnemonic here called STRIDE. So STRIDE is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. STRIDE is a methodology that will help you in the early days of threat modeling when you're sitting there looking at the data flow diagram going, I don't know what the threats are. I don't know what questions I need to ask about this data flow diagram. And so think of spoofing as when on a particular data flow diagram where an attacker is able to pretend to be somebody that they're not. They're able to spoof or send a request that looks like it's coming from somebody else. Tampering is when an attacker is able to modify a piece of data that's going between, for example, an external entity and something, a process or something. Repudiation is a threat where you can't prove somebody did something on the system. So an attacker does an action and you don't have the ability to prove that they did the action. So you say you did that and they say, no, I didn't. And you can't prove that they did. And then information disclosure is a threat where you leak information out of your feature, to someone that shouldn't have that information. Denial of service, the attacker is able to do something to clog the feature or shut down the feature completely so that it has to be reset and restarted. And then elevation of privilege is when an attacker is able to find a problem that allows them to go from like a normal user account to an administrative user account. And so with those data flow diagrams and the elements on them, the different categories of stride apply specifically to certain elements and not others. So you can't have spoofing of a data flow, because a data flow is just a connection between point A and point B. You have to spoof either the external entity or the process. So you've got a little bit of a chart there to help you understand what threats do I need to consider based on the elements. Now, at the end of the day, you're not going to memorize this. And so I'm fine with you just considering using stride to consider all of the different things you see in the diagram. Just know that some of them aren't going to apply. And if you want to memorize or kind of think about these, there are certain ones that line up. Now, one of the other things on top of the stride methodology is really what we call out of the box threats. So you should be also looking at your data flow diagram and going, what if this happened? What if that happened? What if the attacker did this and then that and then this? Start thinking about some of those other threats based on the data flow diagram that you see. You don't have to be constrained to stride. Stride's a great place to start, but asking and learning about these what if style threats is just something that you can do. It's something that you can use to really provide additional types of threats to be considered. Question I get often is, okay, I went through the threat modeling process. I drew a picture. I made a list of 12 threats. How do I prioritize the ones that I need to care about the most? And so I give you here my prioritization formula. Now, let me tell you right off the start, this is not a scientific formula. This is me sharing how I calculate what I'll consider my gut feel about a particular threat. So if we think about the likelihood, let's start there. The likelihood, what is the likelihood that this threat becomes a reality and becomes a real problem for our feature? So we have to consider two things. How hard or easy is it to exploit this threat? And what are the available countermeasures that exist so that we can make this threat go away? Or that countermeasures that can just be, without even making any changes to the feature, we can block or prevent this threat from being a problem. So what we have to do is we have to make a little tick mark there on the exploitation between hard and easy into either the high, medium. We got to make a little line, a little tick mark there. And we also have to make another tick mark for our countermeasures to say, is it hard? Are there countermeasures available or not? And so once we make that little tick mark there, so let's say we look at one of these and we say, okay, the likelihood of exploitation is easy. This is easy to do, okay? But there are no countermeasures available, so that would be a high for likelihood. Now we slide over to the impact side and we say, okay, now we're looking at, does it impact few or many customers? And is it a low damage potential or a large damage potential? So let's say that this impacts many of our customers and it has a large damage potential, meaning there's a lot of data that could be exploited because of this threat. So now we've got a high condition. And so if you have high for likelihood, high for impact, that's a high threat. I tend to round up with these. So if I have a medium and a low, like with that yellow, I call it a medium. And if two are low, that's likely a low. All of that to say, this is not an exact science. This is not an exact formula. This is a structure that you can apply to doing your prioritization of the threats that are available there. But it's not something that's an exact science. So use this. But if you're looking at a threat and you're thinking to yourself, boy, this little formula thing ended up with this, but I think this threat that's the third one down is the one that's the biggest problem for us. Move that one to the top. That's fine. You're not going to hurt my feelings. I'm giving you a structure you can use, but you need to apply your own knowledge and experience into how you use it. So step 4 is about mitigating. And so mitigating is about looking at the categories of threats that we have from Stride and applying an appropriate compensating control. So for example, if we identify a threat with spoofing, where an attacker can pretend to be somebody that they're not and trick the system into doing some action, the compensating control there is strong authentication, multi-factor authentication, having a second factor to the authentication process where I have to have my username and password, but I also have to have a token or a code that's generated on my phone. That makes spoofing almost impossible because the attacker can maybe spoof part of it, but if they don't have the phone, the ability to generate that one-time code that's only good for 60 seconds, it's a blocker to what they're trying to do. Second category of tampering, messing with the data on the wire, for example. Compensating control is encryption primarily, but also hashing that data. So encrypting that data means as an attacker, I can't see the data. If I can't see it, I can't modify it. I can't even try to modify it. So using encryption is your compensating control there. And then repudiation. So somebody trying to change something on the system and then say they didn't do it. Logging is the answer there. Having a compensating control of properly logging what's happening results in that user or that attacker not being able to say they didn't do it because we have a log that says you did it at 4:32 this morning. Information disclosure, encrypting your data is the same compensating control to counter the disclosure of information. Denial of service, we counter that with having a solid site and product scalability architecture so that a simple small amount of traffic can't knock our site offline. And then the final one, elevation of privilege, is the compensating control is having a proper authorization policy and approach to ensure that those normal users can't increase their access and become administrators. And so with threat modeling, it's all about the mitigations. Mitigations are the most important part of what we do here. We can draw the best pictures. We can think up the coolest threats, but if we don't mitigate them and change our design, we're just wasting our time. Then on the documentation side, you can add tests based on threats that you discover. You want to make sure you have mitigation for all threats. And then you need to ask that question and document the picture you drew, document the threats you came up with, document the mitigations, but then also answer the question, did we do a good enough job on this? Threat modeling is a rinse, then repeat approach that we need to take. So this is an iterative process. Like I said very early on, you're never done threat modeling until you end of life, end of ship, take the application off the internet and no longer let anybody talk to it or access it. So as you're making changes to the application, you need to be constantly going back and revisiting your threat model. And so you got to find the proper time interval. Is it every time somebody makes a change to a feature, do we update an existing threat model? Do we do a refresh every 3 months, every 6 months? These are things that you can figure out for your own environment. But just remember, threat modeling is never done, not until that application is removed and gone from the internet. So a couple tools I want to share before we jump into our exercise here. So people ask me all the time, so what's your favorite threat modeling tool? And usually the answer that I provide, most people chuckle at and go, really? But for me, the tool that I like the best is the whiteboard, because in a pre-pandemic world when I could gather a small group of people in a conference room and sit in front of a whiteboard, the dialogue, the collaboration, that's really the powerful thing in threat modeling, is learning from each other and learning about the feature. So I would sit in a room with a couple of developers, a couple of testers, and let them explain, draw a picture what the feature does on the board with a data flow diagram. And then I just start asking questions. Hey, what about this? What would happen if that happened? Like, what would happen if the attacker was able to talk to that and do this? But the whiteboard really enables that. So you've got some whiteboarding, some virtual whiteboards that help in that process. You've got, draw.io, you've got Miro as another tool that let you do collaborative diagram creation. So we've had good success in using that to do remote threat modeling. We've got an episode on the Application Security Podcast on that particular topic. How do you do remote threat modeling in the world that we live in right now? A few other tools I'll throw out there. So Microsoft has a threat modeling tool. It's been around for a long time, probably 12, 15 years, something like that. It tends to be very Microsoft centric. So if you are a Windows, Azure, C# type of shop, then Microsoft threat modeling tool may solve your threat modeling needs. I tend to find it to be technology specific and more difficult to use for a different cloud environment, more difficult to use for other types of technology stacks and stuff. There is a commercial tool out there I'll throw out for you to take a look at. It's called Serious Risk. Some friends of mine created that tool a few years ago, and it's a commercial solution that lets you do threat modeling at enterprise scale. So it has good tracking and collections of threat models, and good integration with requirements and stuff like that. So if you're in the market for a commercial tool, Serious Risk is a potential one you should take a look at. I don't have any other interest in Serious Risk other than I'm an application security practitioner, and I look at tools and I recommend things that I would use if I was building a program right now. A couple of tools in the OWASP world, Open Web Application Security Projects. So there's one called Threat Dragon, which is the closest tool that implements the process that I still teach and use. So I would say, of the ones on the list here, that's the one that I would start with if you've never done anything with threat modeling before, because it's open source. You can download it. You can run it in a browser. You can run it on your local desktop as a Electron style app. But it does let you draw the picture, helps you organize the threats, helps you collect the mitigations, lets you have some export capabilities. So it's a good place to start. Now, I'll also say that we've got OWASP PyTM, Python threat modeling. PyTM is a very different approach. It's using what we call threat modeling as code. So you create a Python script that imports this library, and then it describes what's happening in the feature in code. And then you can generate data flow diagrams from it. You can generate lists of threats. There's a lot of different things you can do there, but it's a very different approach. Now, a lot of developers tend to like it because you're not making them use a drawing program. They're writing code to describe what they're doing. It's also easy to check that threat model into their source code repository because it is just a Python script effectively that calls this, into this library to get the creation of data flow diagrams and stuff. So some different tools for you to consider and take a look at, depending on what your use case is. If you're brand new to this, like I said, I would start with OWASP Threat Dragon as the first thing that I look at, even before the whiteboard, because the Threat Dragon helps you to be able to do some threat modeling on your own using an established process. In the future, you can then take that to working with other smaller development teams, for example, and using the whiteboard to drive that process in a more collaborative way. So I want to spend a couple of minutes here being able to get some feedback from folks and let you use this threat modeling process that I've been describing. And so what I've got here is a pretty simple exercise. You can start to take a look at this picture. And I'll walk you through what's happening in this picture. And then I'm going to give you about a minute or two to take a look at this and just think about what some of the threats are. Maybe throw some of them in the chat or the Q&A, however you want to input the threats that you see here. But as we would look at this, so you've got two different external entities, an attacker and an administrator. They're using this thing called the MD-up protocol. There's an MD-up inbound and MD-up outbound. Think of this like a protocol that's managing these routers and is, sending commands to make configuration changes to these routers that are in some type of managed infrastructure. Now, if you look in the bottom right, a good fun fact about the MD-up I&O protocol is it provides zero confidentiality, zero integrity, and almost zero availability. So security was definitely not a consideration when this protocol was designed. And so if you trace through this data flow diagram, you'll see that we have the admin interface daemon, the configuration database, all in the center part here. And so an administrator or an attacker can try to communicate with this admin interface daemon. And then the MD-up protocol requests are being sent to, routers 1, 2 through N. There could be lots of routers that are out there that are attached to this. And so as you're looking at this now, just be thinking to yourself a little bit about what are some of the threats that you see here. Maybe even throw one or two in the chat as you go. I'm going to walk through this and just give you my initial read on this as far as what threats do I see when I'm sitting down to threat model this particular exercise. And so let's start. We're going to use Stride as our methodology. And remember, spoofing is where, one external entity can try to do something as another external entity. And so I see a case where the attacker could spoof the administrator right off on the left side of this, using that data flow that's coming into the admin interface daemon. There's an opportunity for spoofing to occur there. So there's also an opportunity for tampering to happen. So if that is not an encrypted link, and since the MD-UP protocol lists itself as having basically zero security, there's a good chance that that is not an encrypted link. So the attacker could tamper with the data on the wire that the administrator is sending in as a request. Now, from a repudiation perspective, what is the threat here? Well, the attacker could do an action, and if I don't see logging or any type of tracking of what users are doing in this data flow diagram. And so that attacker, anything they're doing is more than likely not going to be recorded. So modifying data, denial of service, elevation of privilege. Like, think about denial of service. So the attacker could generate a whole bunch of different requests coming inbound to the admin interface daemon, and maybe they could shut down that daemon and make it so that it doesn't work. And then elevation of privilege, the administrator can try, or the attacker can try to become the administrator, maybe by finding a login account that gets them some type of access into the admin interface daemon, but also gives them the ability to try to elevate that privilege and step out. So I just wanted to give you a little taste for what threat modeling looks like when we do this for real. There's a lot more to it. And yes, don't look up the MD-UP protocol. It's something I made up on the fly here. It's made up, the MD-UP protocol. But wanted to give you a little bit of an example of how threat modeling comes together. So key takeaways here coming out of our session as we land the plane here. And I don't see any questions in the Q&A. So if you have any questions, feel free to start dropping those in there now, and I'll address those before we wrap up. Threat modeling, the definition I share with you, is analyzing representations of a system to highlight concerns about security and privacy characteristics. And remember, we do this threat modeling to prevent security bugs that require fixing up to and after release. So we want to fix these things early in our process. I shared with you the process that I use: scope, draw, analyze, mitigate, and document. And then we talked about a few different tools that are available out there to do threat modeling. My favorite is the whiteboard, but I also recommend Threat Dragon as a good place for you to start. And then I guess my final and my largest key takeaway here is the best way to get good at this is to threat model. You just have to get out there and threat model all the things that are available in your environment. So you can sit in a 40-hour class and learn about threat modeling, but really you truly don't understand and embrace it until you're able to perform a threat model and struggle through the first couple, figure out the process that you're going to use, and then you'll start to get better at it. You'll start to see threats materialize as you're looking at a data flow diagram. So that's my challenge to you, in this session, is to threat model all the things. So while I'm waiting for a couple more questions, I see one just came in, but while I'm waiting for a few more, just tell you real quickly, security journey, what we do, we provide security training by developers for developers. So our approach is to provide a belt-based system that has a series of levels that your developers can make their way through, so that when they begin their journey, they can see off in the distance how they can become a security champion by learning at these different levels along the way. Our approach to content, we have a platform that delivers the content. We're quick and conversational. We make modules that are short lessons because we know developers, their primary job is to code. They don't have 8 hours a day to do training. They got to get their coding in as they go. We also try to make it fun and engaging. We don't read off scripts. We don't read off teleprompters. I bring together security passionate people, and we have conversations just like I'm having with you today, talking about these different types of security issues and how do we fix them? How do we mitigate things? The developers and people who are using the platform can receive rewards and recognition. They can earn belts. They can earn levels, certificates, badges, all kinds of things that they can earn along the way. And we do provide hands-on practical experiments for them to take a particular concept and then apply it and, understand how to fix it, how to make it work. So we've got a free trial if you want to test it out at trius.securityjourney.com. That'll let you, without talking to anybody, just jump on the platform, play around with it, see our approach to content, see how we do experiments, and then gives you different ways to get in touch with us to have a conversation. So you'll find that at trius.securityjourney.com. And so I'm gonna jump over to the questions now, but just to give you a couple more thoughts about being able to contact me. There's my email address, my Twitter handles again, mentioning the Application Security Podcast a second time. We also do 5 security articles that are worth your time. So As you might imagine, I love application security, and I collect articles that are interesting to me. And every couple of weeks, we send out a batch of those with a little bit of analysis from me and a video that we do on YouTube, having a little bit of fun with the articles. So that's how you can engage with us. Once again, trius.securityjourney.com just to test out the platform and see how we approach this. So one question that I'm seeing in the chat, in the Q&A box here that I want to address is, question is, how much of a factor is price of the protection in threat modeling? So that is certainly something that we consider, but that's more of a risk management thing for me. So I like to think of threat modeling as something that's a little more pure. So when we think about like risk mitigation and risk assessments and things like that, that's where we're getting in and we are saying, okay, we have this risk to the business, the security risk in this case, and we have these controls. What's the cost of it? And then is there a return on investment on the cost, or are we just going to accept the risk because the cost for the mitigation is too high? I think of threat modeling as more pure than that. And I don't want us to get caught up in trying to answer that particular question about cost. I want us to just think about what are the challenges that sit in front of us and what can we do, to be able to mitigate those. I'll just wait one more second, see if anybody's got any more questions. All right. Well, don't see any more questions in the chat or Q&A boxes right now, but you've got my contact information here. Feel free to reach out and keep the conversation going. I love to talk about threat modeling. And check out trius.securityjourney.com. And once again, thanks to Sunset Learning for the opportunity to be here and speak with you, and go out there and threat model all the things.
Thank you so much, Chris. Lots of great takeaways today. Thank you all so much for joining us today. As I mentioned earlier, I will be sending out a recording of this tomorrow. So if there's anything you want to revisit, you'll get a chance to do that. And that's all we have. So have a great day, everyone.